coefficient of superficial expansion of solid. Coefficient of superficial expansion of solid. Coefficient of superficial expansion of solid. In the diagram, a square plate is shown. L1 is the initial length of the square plate at the initial temperature T1 degrees C. Initial area of the square plate is A1, which is L1 square. A1 is the initial area of the square plate. L1 is the initial length of each side of the square plate at initial temperature T1 degrees C, and initial area is A1, which is equal to L1 square. Now temperature is increased to T2 degrees C and length of each side of the square plate increases to L2. L2 is the final length of each side of the square plate, and final area of the square plate becomes A2 square at the final temperature T2 degree Celsius. Let A1 be the surface area. A1 be the surface area of a square plate with each side of length L1. With each side of length L1 at the initial temperature T1 degree C. At the initial temperature T1 degree C, such that the initial area becomes A1, which will be equal to L1 square. Such that A1 equal to L1 square. Here A1 is the initial surface area of the square plate. Initial surface area of the square plate of the solid surface square plate, square plate. A1 equal to L1 square, which is initial area of solid square plate at the initial temperature T1 degree C. Similarly, A2 be the surface area. A2 be the surface area of the same solid square plate. With each side of length L2 at the final temperature T2 degree C. Final temperature T2 degree C, such that A2 is equal to L2 square. A2 is equal to L2 square. Final area is A2, which is equal to L2 square. A2 equal to L2 square, which is the final area. Which is the final surface area of solid square plate at the final temperature T2 degree C. Now change in area is A2 minus A1. Change in area of the square plate is A2 minus A1, which is directly proportional to A1, that is directly proportional to initial area A1, and also change in area A2 minus A1 is directly proportional to change in temperature, that is T2 minus T1. A2 minus A1 proportional to A1, and also A2 minus A1 is directly proportional to T2 minus T1, where T2 minus T1 is the change in temperature of the square plate. T2 minus T1 is the change in temperature, difference between the final and initial temperature of the square plate. Therefore, A2 minus A1 is directly proportional to A1 T2 minus T1. A2 minus A1 proportional to A1 T2 minus T1. Simultaneously, we can write A2 minus A1 is equal to beta A1 T2 minus T1, where beta is the constant of proportionality, or comma beta is equal to A2 minus A1 divided by A1, which is initial area, into T2 minus T1. Beta is equal to A2 minus A1 divided by A1 into T2 minus T1, which is the coefficient of superficial expansion of solid. Beta is equal to A2 minus A1 divided by A1 into T2 minus T1, which is the coefficient of superficial expansion, which is the coefficient of superficial expansion of solid. Therefore, in words we can write coefficient of superficial expansion. Coefficient of superficial expansion under bracket beta is equal to A2 minus A1, which is the change in area of the square plate, change in area which is A2 minus A1, divided by initial area which is A1 into change in temperature which is T2 minus T1. Coefficient of superficial expansion, that is beta, is equal to change in area divided by initial area into change in temperature, that is the coefficient of superficial expansion of solid, where A2 minus A1 is the change in area, is the change in area of the square plate, change in area of the square plate. Now, unit of coefficient of superficial expansion, unit of coefficient of superficial expansion beta is Kelvin inverse, Kelvin to the power minus 1 and degree C to the power minus 1. Unit of coefficient of superficial expansion is Kelvin to the power minus 1 or degree C to the power minus 1. Beta can be written as dA divided by A dt. In terms of calculus, we can express beta is equal to dA divided by A dt, where dA is change in area of the square plate. Beta is equal to dA divided by A into dt, which is the coefficient of superficial expansion expressed in terms of calculus. Coefficient of superficial expansion, where dA is the small change in area of the square plate. dA is the small change in area of the solid square plate or solid body of initial area A due to rise in temperature or due to change in temperature by dt degree C or dt Kelvin, dt degree C or dt Kelvin.